Yun-Chan Ha from Samsung. So actually, my approach is, as I mentioned in morning session, we're starting season 2 virtualization brigade. So season 2 brigade leader is Cloudy Chiu, working for Sienna, but she cannot attend this event due to she's personal event. So I present this brigade update instead of her. So okay, so I has served as a brigade leader during the last 1 year, and this update will let you know what we've done so far on virtualization based on ONOS. So let me remind you a little bit about our goal and short-term and long-term focus. The first of all, our ultimate goal is very simple. We wanted to provide SDN-enabled virtual network to the user. And this virtual network can be shared physical resources between multiple users. It means that we have to provide multi-tenancy also. To achieve this simple goal, we divided the sub-objective like that. So we need to define virtualization API on both for management and operation. And we also designed virtualization subsystem to provide this kind of virtualization tasks, such as translating physical network and physical resources and physical events into the virtual one, and we optimally how to map this and represent the virtual network in programming model, and also how we also have to consider how we gonna implement the relationship between physical network and virtual network. And also, this one is not implemented yet, but we will, in the near future, we will support that. We also wanted to support multi-protocol, such as PIPO or whatever, NetComp or LISIP. In long-term focus is we wanted to explore more sophisticated use cases to leverage that kind of use cases by providing more advanced capabilities, such as allow external connectivities. So each virtual network can communicate with other virtual network and also can communicate with internet. And second one is about the optimization problem. So we will address more advanced optimum virtual network embedding algorithms and more compressed to reduce each virtual network users for implement their services. And also another important task is we will provide snapshotting. Snapshotting, maybe if most of you guys can maybe very well known about the snapshotting on server virtualization. You can suspend your virtual machine and resume again, or you can migrate suspended virtual machine to another hypervisor. It can be also happen in virtual network also, because virtual network is embedded on the physical network. So we can migrate virtual network from this spot to other spot, and then you can change your service provider also. So indeed, to address this scenario, we also consider extend our subsystem to support virtual network snapshotting. And the last one is OpenStack integration. So nowadays we can talk the cloud. We always talk about cloud computing, and cloud computing is the most buzzword in the world in IT areas. So everybody talking about the OpenStack and cloud computing. To address this issue, we will also support OpenStack, more especially Nova APIs. Okay, so members we consider consist of 60 members. 8 is core developer and another 8 is for testing and the evaluation. Okay, I will skip this slide because sorry. I will skip this slide because I mentioned and I will invited our brigade members to the stage at the morning. Okay, let me introduce briefly software-defined network. Most of you are very well known, very familiar with what is the SDN and what is the benefit of the SDN. So briefly remind you what is the concept of SDN. SDN is a very simple concept paradigm. So it separates data plane and control plane. It's very simple, but the traditional network is also has a similar approaches, but it's closed. So only vendors can program and learn these capabilities which the traditional network device provide. And changing these interfaces and capabilities is very difficult and very costly. But by introducing the paradigm of SDN networks, paradigm shifted. So we just separate data plane and data plane that consists of common devices, very cheap, and you implement your applications and your business logics on the top of the controller. Controller is a centralized authorities to control entire network. So this paradigm looks like a simple, but it includes a lot of things more than compared to the traditional network. So to achieve this simple scenario, there is a lot of SDN protocols such as OpenFlow and NetCompliant and people and whatever. But in this, our brigade focuses on the first OpenFlow first, because OpenFlow is the most widely used OpenFlow SDN protocols in the world, and OpenFlow treated as a de facto standard. So OpenFlow is, it perfectly supports what the SDN brings. So such as a separate control and data plane and the centralized management, and most of controllers and things can support OpenFlow also. So one of the features of SDN and OpenFlow, what we take advantage is programmability. So programmability can allow us, we can virtual network service system directly program virtual network itself. So this is why we're interested in SDN and virtualization. So our design objective for virtualization subsystem in ONOS is the following issues. So the first one, we have to support multi-tenancy. Multi-tenancy means that multiple users can operate, can manage, and can create their own virtual network environment, including address spectrum and topologies and the control functions. So each user can maintain and operate own network. So this is the concept multi-tenancy. And here is another problem. Then when the resources, physical resources are shared among the multiple users, then we have to guarantee that multiple virtual network cannot make any interference to the other networks. So for example, a network operation can affect to the other network, then this is this is not what we deserve. So, and distributed architecture, this is one of the distinguished features compared to the other virtualization frameworks. And the first one is heterogeneous network support, but this is under development, so this is not available feature yet, but we will do then in next few releases. And also we support a new application model which is called on-platform application. It means that the applications for virtual network is natively run on the top of the ONOS itself. And also we support the previous traditional model of the virtualization, such as the open vertex or flow visor support. And we also define a very rich programming APIs also. Okay, let me remind you what kind of virtualization, SDN-based network virtualization approaches are there. So obviously, ONOS already support multi-tenancy virtual network inside under the name of virtual tenant network, VTN service. But this one is based on the overlay-based approaches. This is not purely network-based solution. It's somewhat more similar to the hypervisor-based solution. It means that the open vSwitch or virtual switches are installed on the hypervisor as a virtual machine, and this virtual switches make connections through the tunnel using VXLAN or VLAN or whatever. It's tunneling based, and this is the actual network fabric is not involved in the configuration of the network. So here is another model that is using the SDN programmability. That is direct programming approaches. So in this, compared to the previous overlay network-based approaches, in this model we can directly program network devices itself using SDN protocol, OpenFlow. So we can directly program network device, and we can assign resources, and we can manipulate devices and configure them freely. So this one is can bring more powerful QoS packed advantages. This is why we focused on direct program approaches. So most of the overlay-based network approach is widely deployed on the data center, and most commercial solutions such as VMware solution and Microsoft solution is based on the overlay-based approaches, but still we needed to go more to deploy direct program approaches to the real world, but this is why we are working on to this kind of approaches. I believe that the direct program approaches has more potential to achieve in terms of performance and quality and manageability and availability also. Okay, our target use cases, it can be divided into 3, but we can try to find out more useful use cases. If you have it in mind, I think you can. One of you can have some need to implement to have your own virtual network, whatever, for the testing purpose or before commercialization, you wanted to prove your concept, or in these cases, we need virtual network itself because deploying the real hardware testbed is really expensive. So I think if you have a good idea and good use cases, please let us know, and we will consider to devise your needs and your requests in our development process. Okay, so as I told you, the first use case is obviously we can allow creating multiple virtual network on the top of the shared physical resource. And the second one is we also consider network slicing scenario of 5G network. 5G network is always saying about one of the new features of 5G network is network slicing. So to implement network slicing technology, we can use our virtualization subsystem and scenario. And the third one is federation. It's for multicasting and for the broadcasting and more sophisticated, commercialized in network. There is a lot of use cases. So we cover that kind of use cases through this federation scenario. Okay, this is our overall architecture of our virtualization subsystem. Sorry? I'm sorry that what happened? I don't know. Okay. Sorry for interrupt. So I don't know what happened in the slide. So our architecture consists of 5 layers. The most low layer, they're located protocol adaptation layer. This layer is responsible to communicate with the physical devices through the own protocols such as OpenFlow and OSDB and NetConf and LISP and PIPO. But now we only support OpenFlow, where I expect other protocols will be enabled in the future. And the second tier is application abstraction layer. Abstraction layer is we received some network-related messages, and it converts to the more abstraction, such as device. What is a device, and what is a host, and what is a link, and what is the administration, and that kind of things. The network-related concept is somewhat more abstracted in this layer. Then third layer is virtualization and or translation layer. This one is translate what physical event or physical package into the virtual object. So, and then also in this layer, it figured out which event, which virtual network should receive these messages. And fourth layer is a virtual abstraction layer. This is a layer that originally had the same functionalities and responsibilities come with abstraction layer on the second layer. But this one can be parallelly multiple layers can be exist because per virtual network we provide interfaces. So in this layer, the branch that span out the virtual network services in this layer. And the last layer is application layer. Application layer is you know that where application can be learned. And over there we provide also REST APIs and more REST and CLI and GUI things as a northbound interfaces. And also I will talk a little bit details about their later, but we also have some specialized interface which is called OpenFlow agent. OpenFlow agent allows that our virtual network can communicate through OpenFlow again. It means that you can install your own controller externally, where outside of ONOS, and you can communicate with our own virtual network through OpenFlow. So this is our one of the distinguishing features of our virtualization subsystem. So here is how we implemented our virtualization subsystem. The left stack is original ONOS component subsystem stack. So the most low layer they're located provider components, and in middle manager components are there, and the last layer of application components are there. But in virtualization subsystem, we put two more component layers to address what I addressed in architecture slide. So we put the virtual provider component and the virtual manager component over there, and application is on the top of the virtual manager component. They consume dedicated resources per virtual network. So this is a virtual network representation model. So to provide as similar to the ONOS provide programming model and the entity models, so we extended existing ONOS entity model like that for the ONOS support devices, but we extended device as a virtual device, and the virtual device provide exactly same interface with what virtual real devices in ONOS provide. So this is why we extend existing ONOS model and classes and their interfaces. So if you program virtual network application, then you can recall exactly same entities and interfaces for the virtual network. So this is another one is I want to mention that virtual network entities is is created by you or created by operators. So but in physical network is discovered. So you install your physical hardware, and then using the LLDP or discovery protocols, the SNA controller can discover those kind of things. But in cases of virtual network, every entities are discovered. So to create and manage the virtual entities, we need more special interfaces. That is a virtual network service and the virtual network administration service. The virtual network service only allows query about what the inventory of the virtual network entities, and virtual network administration service allows to create own virtual entities such as device and link and host and whatever. Okay, and if you create your own virtual network using the virtual administration and virtual network services, and you need to manage and operate on the virtual network itself. So To address this issue, we provide virtual network core service modules. Now, we try to provide as many as possible, but I can remember the exact number of the services now we provide, but around 10 interfaces, 10 services are provided for the dedicated, as a dedicated virtual network interface. The well-known one is the device, path, and link, host, flow, packet, group, meter, intent, flow objective. Yeah, we have most the basic services we already provided for the virtual network operations. And one cool thing on this picture is each interface is isolated, and it means that each operations are perfectly isolated from others. It means that we can one operations from the one virtual network cannot packet to the other network, and also they also can be using the own dedicated interface as same as ONOS provide. You know, if you have experienced any developing applications of ONOS, maybe you can familiar with how to consume and how to call ONOS service APIs. But to match with this parallel programming environment as same as like ONOS native application development, we also provide exactly the same interfaces for virtual network operations. So, and this one is a more tricky part, translators. Translator is somewhat more mathematical and more academical topics. So this is somewhat related to the optimization, and this is how you can implement or how you can realize the virtual network request to the physical network. So this is the problem of how you map your virtual network entities into physical network entities. So this is in current stages, we just provide a simple virtual network as a second as figures. We provide subtract flows as a part of the virtual network. So it means that the physical network consists of n physical switches you can use. You can declare you can create a virtual network less than n devices. So more than n devices is we are still trying to figure out how we can provide ambiguous, how can I say, some own topologies also. So this is I do not mention about the details. This is about somewhat more related with math and algorithms. So, but this part is someone who in academia. This is a good, perfect position or perfect topic you can dive into for your paper. And okay, this one is also related with related to providers. Now I mentioned that the providers can be implementing where implementing algorithms and mapping systems. So we can have a lot of requests or needs. So someone needs some cost-effective embedding, and someone needs performance beneficial embedding, or whatever. So someone needs energy-friendly embedding one. So we can think a lot of algorithms and a lot of scenarios to embed and realize virtual network on the top of the physical network. So to address this one, to allow multiple translators or algorithms you can implement, we adapted this flexible virtual providers. So this is each provider working as a kind of module, and you just develop your own algorithm as this provider, and then you can just register onto the provider registry service, and then whenever you can call this your own developed provider, then entire virtual network system working as with what you developed the algorithm. This is one of the features we have. And also we support distributed virtualization operations. This one is very important issue to, that if we can assume that we can support tens of thousands of physical devices, and also we can create tens of thousands of virtual networks also. So to address this kind of huge number of virtual network and physical devices, we have to consider scalability. And also another important issue is high availability. So high availability is always the hot topic and always the important. So to address these issues, our virtual network subsystem also provide two distributed operations. So the operations overhead to virtualize and devirtualize due to the virtualization process can be distributed over the ONOS instances. And event delivery system, this is about the optimization technique. So as I told you, each virtual network each virtual network owns dedicated service APIs. But for this kind of event delivery or somewhat nearly dynamically something produced and consumed interfaces, if you make that kind of too many interfaces and classes over there, then it can cause nearly severe performance degradations. So to resolve these issues for the event or for event cases, we use ONOS event delivery mechanisms. So the event from the A virtual network is encapsulated and then delivered through the ONOS event delivery service and then decapsulated where it should receive. So this is our event delivery system. So, and distributed store is another one. Distributed store is to allow, this is a combination of distributed operations and the reuse event services. So in these operations, we allow two main distribution algorithms. The first one is consistently distributing all informations. So it means that this one is used for the somewhat important and static informations, where what kind of virtual entities are created and managed, and which kind of operations, and not operations, which kind of configurations are there. This one is shared through the entire instances strongly. So in this case, we use consistent map virtual store. But the second one, for the performances can be issued, then we use cluster communications. So in these cases, the result or somewhat report can be shared between the instances, but the actual operation things cannot be shared with other instances. Only communicates where sending the request and where receiving the request. That's all. So they are only the two nodes are involved in this operation sharing and the load sharing. So this is can be through the cluster communication. So we support two types of distribution model. Okay, application model is we provide two types of application. So the first one is you can run your own application on the top of our platform as ONOS native application. And the second one is you can run your own SD controller, and then you can install applications on the top of the external controller. This one is the traditional approaches like as provider and open vertex support. And another one is OpenFlow. In our system support is ONOS native application approaches. It means that you can develop your applications for virtual network as ONOS application development. Okay, applications development is we try to provide as same as the same interfaces calling the ONOS native service APIs. So in this case, the upper piece fragment of code shows how you call device service in ONOS native. But in our cases, we can't do that exactly the same way, but we tried that one through the virtual network service. As I told you, virtual network service allows to query what kind of services and what kind of virtual entities are there. So you can call the service also. So you find referencing the virtual network service, and then through the virtual network service, you can pop up some specific service instances. For in this case, the lower part shows how you can get instance of the device service for a virtual network. me summarize our work for virtualization brigade season 1. So in this seasonal activities, we achieved a lot of things, but not still we need to address a lot of use cases and optimization problem also. So let me summarize in simple word. We prepare, we ready to address your scenarios. So if you have good ideas and good scenarios, please let us know, and we can collaborate with our team and you, and we can deliver more fantastic and more good services for others.
Okay, thanks for the answer.
Thank you.